Morning, everybody. Thank you for being here in this talk from BW Tech. This talk is going to be about the new technology developed with the company about the incoming materials and things to the package. In the last few years, this has been an area that has expanded dramatically, the transfer of the knowledge of the analysis from the laboratories to the warehouse. And we have introduced new technology in the last couple of years to make sure that all the materials can be analyzed in the warehouse. Historically, there has been a lot of progress in spectroscopy, and particularly in Raman spectroscopy. We are very proud in BW Tech that we have specialized in this technology. We have introduced new products in the last 6 years, one product per year, involving pharmaceutical companies, involving warehouses, and involving identification of chemicals. We see the potential of the handhelds, and most of the people understand the potential of handheld technologies in an environment like a warehouse, where you can delegate the identification of the materials to the technician that receives the goods. So you don't need to take the samples anymore, send into the laboratory, try to minimize the manipulation of the samples, try to minimize the cost associated with identification, routine identification of the most common chemicals that you have in there. Raman is very well known because you can read through the packages, but you need to have some limitations in that. One limitation is those packages need to be clear. You need to be able to see the sample to be able to acquire the data. Because of most of the pharmaceutical companies work with primary liners that they are clear plastic, that's fine in most of the cases, and you can analyze quite a lot of those chemicals, but there's still nevertheless problems to accept this kind of technology in some environments. Most of the time, the restrictions that we observe in the introduction of handheld technology is based on existing protocols, so the people are reticent to change the technology they're using. We see the expertise. Sometimes it's a new technology for them, and they are struggling a little bit to introduce handheld technology or portable device into the environment like a warehouse. Overestimation capability of the company. You buy something new, you think you can do it, and then you find yourself that you cannot have the expertise or the capabilities to do this development. And ownership. When you transfer the responsibility to do analysis in the warehouse, who is going to be the new owner of those analyses? It's going to be the warehouse, or it's going to be the QC laboratory. So things like that has stopped some companies to go into that. But nevertheless, there is companies that have enhanced this technology about 5, 10, 15 years ago, and then ask for something else. So we have a handheld technology that works fine. And we can see in this graphic potentially what Raman technology can do. About 85% of the materials in the warehouse can be analyzed more likely by Raman technology. There is some problems with some samples that may present high fluorescence. So those samples represent a relatively small percentage in what can be analyzed or should be analyzed. And then there is other materials, sodium chloride, potassium chloride, that cannot be analyzed by Raman technology, and others that it just doesn't work. Okay? Some dark materials, samples that they are not active in Raman, samples that they are herbal substrate. So those doesn't work. That is in theory. Then you got the reality check. When you go really to the warehouse and you find it that for whatever reason, real operation conditions, those percentages are slightly different. You can see that the 85% drop to 80%. In an ideal world, that is true, meaning that maybe the volume that you have is too small to justify the validation of the technology with those products. Maybe because you cannot access the sample for whatever reason. Must be stored in cold conditions. It's just not accessible for the technician to take the spectrum. So at the reality, at the end, the 4 or 5% become an 11% because sometimes you cannot see or you cannot access the sample in standard conditions. That is where this new technology in Raman introduced a difference. What happens, for example, when you have samples like sucrose in paper bags? In that one, there is no secondary liner. So it is just directly the sugar. If you open, you're going to have the sugar out of the spilling. So you need to go to the sampling area to do the test. So the handheld benefit is just lost. Or sometimes you have small bottles like those one. They are opaque. that you cannot see what is inside, so you don't know if it's going to be accessible or not to have your spectrum on that. And very likely, if you take a Raman spectrum of that, what you will see is basically the plastic of the bottle. So there is some limitations in these kind of samples. So this is where this technology plays a role. So what we have done is to create a new spectrometer, a new Raman technology. It's a little bit larger than handheld, it's still portable, but we need to have much higher efficiency in terms of collecting the Raman signature. And what we have is basically a very large beam of laser that is going to focus in a very large section of the sample that we are going to analyze, collect coaxially the light, and then we're going to have a very powerful spectrometer that is able to catch that light. Then mathematically, we process the data, and we are able to identify the materials that is hiding underneath that. These need to be identified logically. It's a pharmaceutical environment with validated libraries that need to be compliant with your regulations. What this technology introduced, the capability to do Raman in an area that was limited up to today. This means measurement through opaque materials. We cannot do all materials. Let's go be clear on that. Let's go put the expectations in the right level. We can do a lot of new materials that in the past were blocked by the technology, a standard handheld device. But we can go now in materials that they were opaque, and then we can be now analyzed. As well, we have identified that the introduction of this technology introduced quite a few important new factors. For example, in the past experience, we identified that standard handheld devices have a high energy in the point of analysis. What we identified out that with this new technology, for example, samples that were thermolabile or unstable because of the radiation of the technology, the Raman technology, now we can use it, again, to identify because the power density is very low. What we can do is, those are traditionally the bottles that we can, but in some of the customers that they are purchasing this kind of technology, they are introducing us new areas that we didn't conceive initially. For example, some customers do have problems with the ICSE environment, where they have plastic containers. We cannot do the metal drums, but we can do practically almost all plastic containers. They have problems, for example, with the ICSE environment. They need to open the samples or sampling the area in a very specific environment. Now with this, they can do outside the warehouse, directly on the reception of the material, analyze on the spot. It is identified, they can go inside the warehouse. That simplified dramatically the way that the instrumentation is introduced. Most of the time, we have customer requesting what kind of packaging really you can see through. A reality check again. So basically, practically all the polymers that they are used in the pharmaceutical industry, as long as there is no treatment or a secondary wall that is blocking the light. So if you have a PAT or PPT or anything like that, there is a primary liner or a secondary lining of that material, that's perfectly fine to analyze through those. Thickness, there is not too much limitation. Few millimeters standard thickness is feasible. There is limits. We cannot do absolutely everything that can be inside those drums. We can do practically all glass. Again, limitation with common sense of what is the thickness of the glass. And some of the paper and cellulose lines that they are using. We have a limitation that is the presence of cellulose on those papers. So cellulose presents sometimes problems of fluorescence. If there is fluorescence, again, that's a problem for Raman spectroscopy. What we cannot do, and in fact nobody can do, is read through fiber drums. Those cannot be read. Basically, the light is diffused too much and blocked too much to reach the sample. And there is a thing of role in this. If the light cannot reach the sample and cannot come back, the technology cannot be applied. Okay? The example, as I said before, mostly all plastic can be read through, but we have limitations sometimes with the copolymer agents or some of the resins or colorants that they are used because they can block practically all the light. They are, in fact, containers designed to block the light. So in those cases, we cannot do. We cannot do anything involving metal. The technology is a laser, so we need to be able to pass the light through the material to be able to read what is inside. So if we apply the rule of thumb that no light, no Raman, we can understand pretty quickly what are the limitations of this. But outside that, practically any other drums, any other packaging material can be read through. The example of sucrose and cellulose, those are the most common ones because those are materials that they don't have too many layers. So normally they are shipped with one single layer to understand or to read through. Those normally are paperback. Most of the paperback can be read through. Not all of them. Again, the limitation is the presence of fluorescence in that paperback. I think that's the same one as before. And sometimes, normally the QC department, that is the one that normally requests information about this technology, is can we use this exactly technology for something else? And that is information that comes from the customers to us. There's ideas that they have, and we try to implement it. The technology has proved to be very efficient for final product control. For example, for content homogeneity. Because you do a very large area of analysis, you can see perfectly through and do transmission Raman with exactly the same device. Bio applications, again, customer requests, can do analyze proteins, can we analyze in vivo elements that they are using in the industry? The answer is yes. We are not damaging the samples because we use very little power density, so we can have a very nice Raman signature to identify and correlate the biomarkers that we have in those materials. Traditional difficult samples, for example, dark samples. A classical example is Raman is not suitable to use black powder. I know it's pharmaceutical environment and you don't care about black powder, but black powder and Raman are not compatible. Now we can. Now we can do the analysis of black powder with this technology. This is an example of a final content analysis with the ST technology. So we have a perfect, sorry, the laser doesn't work for this. So we have perfectly understanding of the different components that we have in there. If you try to analyze those tablets, the content in titanium oxide and sucrose on the coating is so strong that basically you don't see anything that is inside on the core of the sample. So this technology allows you as well, not only to read through the packaging material, but as well through the coating of the material in the final product. So that helps you as a QC tool to extend the capabilities of this technology to final control quality and to process control as well. Sometimes we have the classical question is, can we use real samples? Those are real samples from customer. So can we use this for identifying clinical trials if I can use this technology to analyze the chemicals before going in there? The answer is yes. So we can do potentially quantifications. We can do, in many cases, it can be quantified to a very precise level. It depends very much on the matrix and the packaging that we are going to have in those particular elements. The answer is yes, we can do quantification in those systems and we can identify what is in there. We cannot do trace analysis. We cannot do very diluted samples. That is beyond the expectation of the technology of what Raman can do. But in samples like those, powder samples, we can identify directly on the final packaging, and we can identify and quantify with chemometrics the content of the different materials they are in there. So that is the example I mentioned before about the black powder. Black powder, black materials in Raman, they don't go together. They absorb the radiation and they basically are incompatible. But that is the example that we can do the analysis of those materials again. One of the more common questions as well from the customer is paper. What is the response of the paper when we do the analysis? Because, okay, I can tell you it works, I can give you an example, but then show me examples of that, real cases. We take the paper that gives more problem is the yellowish. That one is potentially, for example, for the manila envelopes. Those one we have done many tests for that, particularly for the security sector. And you can see clearly on your right, my left, the difference in between the quality of the spectra that you can obtain directly reading through one of those papers. Those papers are multi-layers. So we have the paper, then we have a plastic that is a polymer, and then sometimes we have bubbles, paper bubbles. So we can read through all those different levels and still having a positive identification at that level. It doesn't work with all papers. It doesn't work with all materials, depending on the scattering properties that you have. But as a general remark, it does work. Everything is associated with software, particularly in the pharmaceutical environment. So BW Tech has been in the market for quite a long time, so this issue is not an issue for us, or this is not a problem, as well as to have a technology that really use quite push algorithms to be able to be sure that what we read is what you obtain. So we have spent a lot of time and energy validating all the technology that goes associated, not only from the Raman perspective, but as well from the software perspective to be sure that complies with expectation of this market. This is another classical example of those PAT bottles that we see on the previous examples. And here you can see the areas that they highlight the contribution that you can expect on those spectra. That is a typical TPEC envelope. I don't know if you are familiar with those. It's a polymer plastic envelope that contains some level of polymers on it. You can see perfectly how you can able to identify the content inside mathematically processing, but you are able to have a very good correlation factors. In terms of sampling area, remember, so we are large the area of analysis quite a lot, so that has important implication in the thermal stability of the sample. When you use standard Raman handheld technology, it's a focus being into a single in a single point. Some people are concerned to have thermal damage in that particular pot. This technology do not have these kind of problems. Then the people as well often come to us and say, okay, very nice instrument, I want to use this kind of thing, but I have budget for one instrument, I want to do everything else. Well, the technology can be adapted, and we can supply the necessary tools to transform an ST system in a standard Raman device. So that is something that is not implicit that you need to use this technology only for that job. So we have prepared the technology to be able to be versatile and provide a number of accessories that they are necessary. So this product, basically what it's trying to complement is the offering from BW Tech in the area of pharmaceutical warehouse. We introduced 6 years ago handheld Raman, so it's an area that we know very well how it works. We have a lot of expertise. That is what the numbers of 80–85% comes from. So we have been selling hundreds of those instruments on the wall. Then a year ago, we introduced nanolipes, laser-induced breakdown spectroscopy, again for the pharmaceutical market. Salt is one of the most common chemicals used in the pharma industry. We can do the analysis now again in the warehouse. So we're still developing to support the warehouses, developing the pharmaceutical companies. That's why we introduced the iRaman Pro ST. So those 11% of materials that we were lacking in our portfolio to address correctly for the pharmaceutical market, now we can address the need with this other product. So the portfolio, basically what try to address is the pharmaceutical warehouse needs. Basically, with those, we cover, I will not say 100% because that is not possible, but we are in between 90–95% of all the capabilities of analysis that you may have in a warehouse in a pharmaceutical environment. With this, just thank you for your attention. If you have questions, I will be happy to respond.